keynote speaker for the day is from the city of Madison, Yan Tao, who works with the traffic engineering department of the city.
Good morning, everyone. My name is Yan Tao, and I'm the interim city traffic engineer and the parking utility manager for City of Madison. Someone asked me to come here, talk a little bit about Madison's Smart City Initiative, and particularly one of the projects that are under the umbrella, which is a Smart Park Street Corridor project. I've been leading the initiative, but over here I want to thank various city agencies and the UW departments involved in these initiatives. Without them, this is not going to be possible. We have a lot of agencies being involved from the city, like information technology, metro transit, planning department, economic development, engineering, fleet services, lots of them. At UW, I particularly want to thank the TOPS Lab and also computer science department for their contribution to the initiatives. First, a little bit background. Just some transportation statistics. Lots of us know this already. The city covers 94 square miles. But if you look at the land, that actually only 70% of those are land, 30% water. If you look at the downtown area, that number is much smaller. Probably we're looking at the 30% land, 70% water. Population, a little bit over 250,000. But if you look at the greater metropolitan area, we're talking about almost, that number almost triples. We maintain about 764 square miles of streets, 220 miles of bicycle facilities. Our transit ridership averages about 15 million rides per year. That's excellent for a smaller state like us. And we maintain about 350 traffic signals. Some challenges we face in transportation, including unique geography. We have a narrow isthmus through downtown. Everybody's familiar with that. Also, over the in about 1950s, the community turned down a proposal to build a freeway through downtown Madison. I personally think that's a very wise decision at that time. That creates a very livable downtown area. But in the meantime, we do have to rely on lots of smaller streets to move traffic through the downtown area. Our population is growing rapidly. Actually, we are the fast-growing region in the whole state. Our demographics are also changing. Our population is getting more diverse and also older. So, how to provide equitable accommodations for everyone, that's going to be a challenge in the coming years. Environment, we love our lakes. I want to protect them. And also, for transportation, the change in technology in the industry. I'm going to talk a little bit more about that later. On the opportunity side, though, we have built a very robust multimodal transportation network, and we have more work to do on that. And we have a complete streets policy to build the streets, not just for autos, but for everyone, for pedestrians, bicycles, for people on wheelchairs. The city also has a strong racial equity and the social justice initiative, and we want to provide access for all our residents. We're doing more and more on travel demand management. For example, we just set up the first Transportation Management Association, which is TMA, in the city of Madison for the Madison Yards Development Project at Hill Farms. So we have to think more about relying on other mode transportation instead of continuous expanding the roadway. Better system management to improve the efficiency of the existing network. And also finally, how to make the whole system much more smarter, which I'm going to kind of address that kind of with this initiative. I'd like to share a story with you. Something I think about happened April 3rd, 2017. The story involves two companies. The first one is Ford, household name company, and was founded in 1903 by Henry Ford. Coincidentally, another company, Tesla, is founded exactly 100 years later, in 2003. If you look at 2016, Tesla sold 76,000 vehicles. Ford, on the other hand, sold almost 7 million vehicles. Ford has a huge profit, about $6 billion, while Tesla had a big loss, almost $1 billion. Well, on April 3rd, 2017, the market value of Tesla overtook that of Ford. So at that time, people think it's crazy, right? So including one of the financial analysts from Goldman Sachs, he told everyone to sell off Tesla stock as soon as possible. However, though, a week later, not only the stock value of Tesla stayed up over there, it also grew and also overtook that of GM. And it became the most valuable automaker in the United States. Again, if you compare the statistics, vehicle delivery, and revenue, and net income and loss, there is no comparison. So Tesla is performing very poorly. But if you look at the market cap, it's on top. So the market is crazy, right? I like that picture from Elon Musk. And this is how Elon Musk defends this phenomenon on Twitter. Tesla is absolutely overvalued if based on the past, but that's irrelevant. A stock price represents risk-adjusted future cash flows. So the future is the keyword here. Talking about future, I would like to share a couple of quotes with you. The first one is from Mary Barra, the chairman and CEO of General Motors. We will see more change in the industry in the last 5 to 10 years than we have in the last 50. The second quote is from a councilwoman from city of Santa Monica, California. The challenge is that we don't know what's coming, but we know it's coming. We all have to learn to change on a dime. I definitely agree to that, but I also want to add that not only we know what's coming, but really we don't know when it's coming. So here is an example. There is an organization called the National League of Cities. Late 2015, it pushed out a major report. It's called the City of the Future, Mobility and Technology. In the report, it made a few bold predictions. One of the predictions is that the big change. By 2030, driverless technology will be deployed in fleets of taxis and buses. So at that time, we're talking about the 15 years. Well, just a few months later, September 14th, 2016, we saw this headline. Uber starts self-driving car pickups in Pittsburgh. So things happen much faster than anybody thought. So to help the different cities to prepare for the oncoming changes, US DOT had a brilliant idea. So they put $40 million together. They want to give to one city to develop a system as a model for the future. Madison participated in the competition. We didn't win the $40 million, but actually it'll be $50 million because Paul Allen from one of the Microsoft co-founders actually put in another $10 million, mainly for vehicle electrification. So we didn't get that. The winner actually was Columbus, Ohio. But we did use the process, developed a plan, and we valued a lot of good ideas come from there. So we kind of continue to push through. So our plan is called Building a Smart Madison for Shared Prosperity. So keywords here are smart and also shared. I kind of mentioned this a little bit already. We were able to gather around us a lot of partners, with the main one, the university here. So our plan has 3 main components: intelligent data connection, analysis, and sharing, autonomous connected and electric vehicles, and also smart infrastructure. So for the first component, data component, the core is a shared Madison data platform. So it archives all the transportation and other data in the city, and we make it open for everybody, not just for government agencies, but also private entities and individuals. We want to do performance analytics. We want to develop ride sharing and microtransit algorithm, for public use. Algorithm for real-time processing and sharing data from all the sources I mentioned. And we want to encourage application developments. So our belief is that governments are good at gathering data, but we're not really good at develop apps. One good example that the community has saying is that Metro Transit made the bus location data open. One members of the community developed an app, bus reader, right? That becomes very successful in the community. All the people, different people benefit from a lot. So we want to encourage those kind of developments by taking advantage of the data that were made available. We want to develop a smart parking algorithm. One common problem we have now is that, especially in the downtown area, people spend a lot of time circling around looking for parking spaces. So we want to make that a much easier process. And a single fare payment system. So one system to take care of all your transportation needs and other needs, like parking, bus tickets, B-cycle rental, and others. And the smart free delivery. So right now, a couple of problems we have for free is that the free delivery is often one way. It comes with a lot of load into the city. When it's leaving, it's empty. So it's a lot of resources being wasted. Secondly, we have tons of loading zone issues in the city as the curb space becomes more and more valuable. So we want to make that process a little bit easier. Also want to support real-time transportation system simulation for decision making. For vehicle technologies, we are looking at autonomous microtransit pilots that have been working with UW and a few other major stakeholders in the city. UW has some Innova Dash electric vehicles, and we want to see more of those. We want to provide mobility on demand G2G services. We also want to implement and take advantage of the DSRC technologies, especially at key locations such as signalized locations, railroad crossings, and for transit use. And we want to provide EV parking spaces with smart chargers throughout the city. On the infrastructure side, we're looking at building a network of thermal and environmental sensors, air quality sensors, things like that. We are going big on adaptive corridor system that I'm going to talk a bit more later. We also want to build a city-owned 5G network and connect all the public safety, public works, and transit vehicles to it. Actually, we have some really good conversation with Suman and his group over here on some of those initiatives. And we want to make our street lighting system smarter. We're working with utility companies to improve the grid system, and we want to implement more advanced collision avoidance systems. We also have a ITS strategic plan, and there's a lot of good projects identified in there. We really like to accelerate the development of those. Some of the ongoing initiatives that's happening in Madison right now. The state-of-the-art traffic signal system that we're building, the adaptive traffic signal control technology, smart street lighting, the connected vehicle corridor on Park Street that I'm going to focus on a bit more today. Also, some autonomous vehicle pilot projects under the US DOT AV Proving Grounds. I think Malha probably mentioned that this morning already on some of those. And also our involvement in the Smart Cities Collaborative. So by taking advantage of the robust fiber optic communication network that the city and its partner has been built over the years, we are bringing all our traffic signals online into a central management system, and we're using the advanced traffic controllers that's compatible for next generation technology. So we're building a state-of-the-art management system for signals. So we know exactly goes on at each signal at second by second, and that has been very useful for us to do troubleshooting and also changing timing on the fly, for different kind of events, crashes, and other congestions. And we are deploying innovative detection and count systems, not just for motor vehicles, but also for pedestrians and bicycles. And we're building a pretty advanced performance measurement systems so that we know how we do and where we can improve. Adaptive signal control technology. We did our first corridor on McKee Road, Pichatre Road. What it does is that the traffic signals knows exactly what's going on at the upstream signals and downstream signals along the whole corridor. So it can adjust timing itself automatically, depends on what kind of traffic are coming at them. So that has proved to improve efficiency by up to 20%. There is a third party did a study on that. We've been pretty happy with the results. Seeing the reduction in congestion, number of stops, and emissions. Actually, we won the Project of the Year award from ITS Wisconsin. Actually, we are building a second corridor right now on University Avenue. That's from the University Hospital area all the way to the west to the city limit. For that one, we received a federal grant for that. We did the design. It's going to be constructed this fall. We also received some grant from the state to do another corridor on East Washington Avenue. That's from Blair Street all the way to the west, all the way to the east, to the Easttown area. And we have more corridors in planning. Smart street lighting, we want to make it more energy efficient. We want to make it connected so that we know what's going on with the lights. If there is an outage, we know immediately, so we can go out and fix them instead of waiting for days and months, leaving it dark out there. We can also, adjusting the light intensity depends on the different situation. It can also be a host to other smart city technologies, such as different kind of Wi-Fi devices and other sensors. We are building a smart corridor on Park Street, basically piloting and deploying connected vehicle technology to improve safety, mobility, bus on-time performance, and equity along the corridor, which I'm going to talk a little bit more later. The goal is to make Madison and Wisconsin as an upper Midwest hub for connected vehicle and autonomous vehicle deployment. Some of the AV pilots, what we're interested in this technology is for microtransit to solve some of our first mile, last mile problems. Sometimes it's not feasible to have regular bus services, to smaller neighborhoods. With these driverless smaller shuttles, we may be able to solve that problem. This is the Wisconsin Automotive Vehicle Proving Grounds. I think might have already covered. The university is a lead on that. City of Madison is a founding partner. Different kind of facilities in the proving grounds. And in the city of Madison, we have done a lot of stakeholder and public engagement, from the stakeholder summits to newspaper reports, and also Capital Times did a talk events on autonomous vehicles. We saw a lot of attendance from the public. Had some really good conversations on that. Really quickly about the self-driving future. It potentially offers a tremendous amount of benefits for transportation safety, mobility, improves the environment, equity for seniors, disabled, and other underserved, also economic development. But on the other hand, though, it can also become a dystopia, if the technology head into the wrong direction. For example, as the driving becomes so easy, people may abuse it. Instead of living somewhere in the city, people might choose living further out because real estate is much cheaper further out, and they have a long commute comes in every day. But since the vehicle is driving itself, people can sleep in the car or work in the vehicle. So what the heck? And when it's coming to the downtown area, so you may not want to pay for expensive parking. So you may just send the vehicle back home. Or even worse, like vehicles circulating around on the streets to avoid parking fees. So if that happens, we can look at increase in VMT, pollution, and congestion. So that we definitely don't want to see that happening. So right now, the technology is mainly controlled in the hands of a few. So that's kind of dangerous. So collaboration across these sectors is needed for a greater public good. We need a government policy. We need academia doing research. We need a collaboration from industry. We also really need to engage the public so they can be part of the conversation. Last thing I want to mention is the city's involvement in the Smart City Collaborative. It's an initiative by Transportation for America, a nonprofit in Washington, D.C. associated with Smart Growth America, and also Sidewalk Labs, which is a part of Alphabet, which is also Google's parent company. They selected the 16 cities over the country to form this collaborative to work on new mobility issues, how to make the system smarter. And Madison is one of the cities that was selected. The 16 cities have been meeting frequently, both online and in person, working on different kind of projects. That has been very helpful process for all the cities involved. Actually, our Smart City initiative has received a lot of recognitions. Most recently, we were told that we won one of the major awards in the industry, the 2018 Transportation Achievement Award for planning. That's from the Institute of Transport Engineers. We won the award at both the Midwestern district level and also at the international level. So actually, I will be traveling to Minneapolis to receive an award next week. A little bit more information about the Smart Park Street corridor. We have a need on Park Street. Park Street is often very congested as part of the special events from the co-center, from the stadium. Also, it's a major transit corridor. We have some bus on time issues, and we want to do something with smart cities. And also there is a call for SPAC challenge. I'm talking about it a little bit later. So the goal is to make it Wisconsin's first connected vehicle infrastructure. Actually, it already is. And one of the first cities in the nation to meet the V2I deployment goal. So the SPAC challenge. So the SPAC stands for signal phase and timing. It can be obtained from a traffic controller via a query. So the challenge is that for all 50 states by 2020, equip 20 intersections with the technology. And this is where Wisconsin can do it. DSRC is the dedicated short-range communication. It's part of the ITS radio service communication frequency band reserved by FCC. It coexists with some other federal users and also some commercial satellite operators. So why we select Park Street? Because of the location, it's primary arterial connection from a bound line, the only freeway we have, to downtown Madison and UW campus. As I mentioned, it's a major transit corridor. Serve a lot of primary special event route. It's also emergency route for fire station and a few regional medical facilities along the route. It has a lot of freight operation. It also serves quite a few low-income neighborhoods in the city, which had dependent on the bus operation. So the scope is to, for each of those green dots, the scope is to build the technology into infrastructure at those locations along the corridor, and develop a bunch of safety, mobility applications, and also by improving bus on-time performance to improve equity for residents living along the corridor. We're also going to make a system open to private partners for vehicle to infrastructure, vehicle to vehicle, and vehicle to everything testing. Vehicle to everything mostly means vehicle to pedestrians and to bicyclists, for example. One of the major things we want to do is the next generation transit signal priority. Currently, some other cities have the transit signal priority, which is called TSP, but it's mostly in a pretty traditional system. Basically, the signal knows whether a bus is coming or not, and then provides a priority for buses. What we want to do here is brand new. It's going to be next generation. Not only we know the bus is coming, but we know how many passengers on board, because you want to treat it differently if there are 50 passengers compared to only 2. We also know, which bus is going to connect to, whether that bus is on schedule or not. So by making all those considerations, we want to do a much better system. Another major application we want to do is for pedestrian safety. For example, when vehicles making a turn, one complaint we often got from public is that they're not yielding to pedestrians. Sometimes by behavior, but sometimes it's hard for drivers to notice the pedestrians if pedestrians start a bit late, especially for larger vehicles like buses. So what we do is that when there is pedestrian cross the street, we send the turning vehicles an alert, let them know that a pedestrian in the way, be careful. So hopefully we can reduce the number of crashes and fatalities resulting from that. Some other applications that I'm not going to elaborate too much here due to time constraints. So project team, City of Madison, different city departments, UW Madison TOPS Lab, Computer Science Department, private partners like Econlight, Siemens, and others. This is the timeline of the project divided into 4 phases. So right now we have 3 locations that's already being equipped with technology. We're doing some testing right now. Estimated project cost is about $1 to $4 million, not including the preparation work like bringing fiber optic to the signals, which city already completed. There is a big range on the estimates because depends on what kind of applications we eventually wanted to do. And by working with different partners, we're looking at potential findings, some federal grants, private partners, and some city share. So right now, it's mostly funded by our private partners. So we got other equipment free from them. So that's how we getting started now. This project also get a lot of positive local and national media coverage. This one is from the National Operations Center of Excellence. So they feature our project on their website. yeah, by going there, you can get more information if you're interested. With that, thank you very much, and I can take a few questions if there are any.